Good morning, students. It's my pleasure to introduce this new CDT on class circular queue. So now I would like to share my screen. I hope my screen is visible to all of you. So this is week 7, lecture 1. Topic is circular queue. So in the previous classroom, we had a discussion on a linear queue data structure where we are performing these insertions and deletions at different ends of the array. Insertion will be done at rear end and deletion will be done at front end of the queue. And that linear queue always follows first in first out order when we are performing these insertions. That is when we are adding an elements into the queue and also when we are deleting the elements from the queue. So what this is the linear queue we discussed. Now the today class lecture objectives is that why we need the circular queue and the implementation of the circular queue we are going to discuss. The lecture outcomes is that upon completion of the CDT, students will be able to develop the code for implementation of the circular queue data structure using arrays. So why we need a circular queue? So in the linear queue data structure, so what we have here is that suppose you have inserted an element. Okay, so these are the array. So where you have inserted the elements like this, and if you assume that the total size of the array is 8, and this is the front element, so which is pointed by the index variable front, and this is the 7 is the rear index. Okay, this is the rear index pointed by the rear end of the queue. So now if you try to call this enqueue function, so if you call this enqueue function, so what in the linear queue what it does is that it will say that, so enqueue of 35 if you call this, so by the condition what we have written in the insertion operation, so since front is equal to 0 and rear is equal to the max size minus 1, so if you are assuming that the maximum size of this queue is equal to 8, so maximum size if you assume it as 8, then since rear is equal to max size minus 1 and front is equal to 0, now we will say that queue is overflowing or queue full. So we will say that queue is full. So now if you again after this if you call dq, that means delete queue if you want to call that, then what it does, it will remove this element 54 and then f is pointing to this index 1. Fine. So like this here, if you are calling sequence of operations, okay, so if you say that after performing the two delete queue operations, now the front is at second index and rear is always at the seventh index. Fine. So like this here, if you see that what is happening here is that, so even if there are some empty locations in the queue, okay, even there are some empty locations in the queue, so we are saying that the queue is full, we cannot insert some data. Why? Because the rear is equal to max minus 1. That is the condition we have written for checking of the queue fullness. Fine. So to overcome this problem, so we need a solution that we need to organize this or we need to shift these elements to the left so that the vacant space can be occupied and utilized efficiently. But this can be very time consuming, especially when the queue is quite large. And the second solution is that we have to make use of a circular queue. So in the circular queue, the first index comes right after the last index. So conceptually, you can think of a circular queue as shown in this following figure, like this here. So the 0th index, okay, so is again the last index is coming, uh, what we can say it as the uh, left of this 0, it is coming that. Fine. So this is what we are calling it as. Then these are the conditions we have to check when we are inserting a element into the circular queue. So the queue will be full when front is equal to 0 and rear is equal to max minus 1. Fine. So if front is equal to 0 and rear equal to max minus 1, then circular queue is said to be full. And if rear is not equal to max minus 1, then rear will be incremented and the value will be inserted. So if front is not equal to minus 1 and max is equal to, front is not equal to minus 1 and max is equal to, rear is equal to max minus 1, then it means that the queue is not full. So there are some empty locations. So we have to set rear to 0 and insert the new element there. So these are the steps. Check for overflow condition. Make two checks here. First, to see if the queue is empty, and second, to see if the rear end has already reached the maximum capacity while there are certain free locations before the front end. So third step is the value is to be stored is queued at the location pointed by the rear after seeing how a new element is added into the circular queue. And these are the conditions for DQ operation. So if front is equal to minus 1, then there are no elements in the queue. So the queue is said to be underflowing, that is empty. And if the queue is not empty and the front is equal to rear, then after deleting the element at the front, the queue becomes empty. And so front and rear are set to minus 1. This is another important condition. If queue is not empty and front and rear is equal to pointing at the same location, that means only one element is present in the circular queue. Okay, only one element is present in the circular queue. This condition means, so that means after deleting this element, one element, so there are no more elements, then what we have to do here is that you have to set front and rear to minus 1. So the queue is not empty and front is equal to max minus 1, then after deleting the element at the front is set to 0. So these are the steps. First step is check the underflow condition. So value of the queue at the location pointed by front is stored in some val. Make two checks here. First to see if the queue has become empty after deletion, and second to see if front has reached the maximum capacity of the queue. So the value of front is then updated based on the outcome of the checks. So circular queue operations. So this is the program, complete program implementation. So we are assuming that the maximum size of the array is 6. Fine. And then front and rear is equal to initially kept at minus 1. So this is a NQ. So NQ function. So we are passing the element which you want to insert into the circular queue. So the first condition we are checking here is that if front is equal to minus 1 and rear is equal to minus 1, so we have to say that the condition is queue is empty. So we have to keep front at 0 and rear at 0, and then insert q of at rear location is equal to element. Suppose if rear plus 1 percentage max is equal to front, the condition to check q is full here. So that means if rear plus 1 percentage max is equal to front, then the condition is there is said to be, that means here front is equal to, the condition other way you can check here is that if front is equal to 0, the other way condition is that if front is equal to 0, okay, and rear is equal to max minus 1. So if this condition is also true, that means we can say that the queue is full. So if queue is full, okay, we have to simply print the message. So if the condition is not true, then what we are doing here is that we are incrementing the rear. So that is done here. How we can increment the rear? So rear is equal to rear plus 1 percentage max, and q of rear is equal to element. So this is what the case here we are taking. Okay, this is NQ operation. Then coming to the DQ delete operation. So DQ function, if front is equal to -1 and rear is equal to -1, this is Q is empty. So we have to just print the message Q is underflowing. And similarly, front and rear is equal to same. Okay, that means the single element case. This is only one element is present in the circular queue. Okay, single element case. This is one element is present in the circular queue. The deleted element should be Q of front, and front is equal to -1, rear is equal to -1. Else, then what we have to do here is that the deleted element is equal to Q of front. So front is equal to front plus 1 percentage max. Okay, so this is what delete Q operation is. The next we have to display. So we have to display that queue from front to rear. So while we are displaying the queue, just you have to check whether the queue is empty or not. So front is equal to -1, rear is equal to -1, queue is said to be empty. Otherwise, elements in the queue or you are displaying from I is equal to front. So I is equal to front, you are initializing I value as front. From front to rear, you have to display that. So I less than or equal to rear, print percentage q of I, then I is equal to I percentage I plus 1 percentage max. Okay, so this is what the for loop we are using, just like displaying an array. Fine. So this is what we have seen. So you can combine all those three functions into a main function. So you can develop the code for menu driven for inserting option 1, delete second option, display third option, and enter your choice. Like that you can create a menu by making use of switch case. You can call based on the input choice, you can call the respective function. Fine. This similar to the queue as well as stack what we have implemented, that same way you can do it. Now coming to this reflections part 1. So what are the conditions for circular queue full? Anyone can tell me? Yes. So if front is equal to 0 and rear is equal to max minus 1, we can say that queue is full. So if you are not able to answer this question, please watch the video from the beginning. Fine. So after completion of the session, students will be able to develop the code for implementation of circular queue operations. So summary of the session is that in the queue, linear queue, so we have identified the problem that even there are some empty locations before the front we could not able to insert because of rear is pointing to the max minus 1 index location. So to overcome that particular problem, we are making use of these circular queues where we are rotating these index variables front and rear in a circular manner. Fine. So thank you. And this is what the lecture level practice problem. Justify this answer. Circular queue implementation using arrays is better than linear queue implementation. Fine. So because of memory utilization, effective utilization of the memory. This is further readings. So you can go through this further readings on this particular topic. Fine. So thank you and all.